Faye has joined us at the last minute to give an update on a project that's ongoing. This is very much an initial pass, work in progress. She's the head of maths at Stanwell School in Penarth and directs the local proof of concept for a national initiative in Wales to investigate how Haskell can be used to create domain-specific languages for professional learning in mathematics. Over to you, Faye.
Okay, I'll share my screen. Please let me know if you can't see my screen. Can you all see that?
Yeah.
Yeah. Okay. So before I start, I just want to say that the toolbar, the PowerPoint slides that I've got, I've actually lifted from the Welsh Government documentation, so I can't take ownership of those, and I would like that sort of highlighted from the start because the wording from what you'll see on the slides is not my own, it's from Welsh Government and from basically the what's called the Maths and Numeracy ALOE documentation, okay? But we now in Wales are having to follow a new curriculum. We started it last year with our current year 7, with the objective that we have to be assessing our now year 8s in 2027. Okay, please correct me, Liam, if you think what I'm saying is wrong. So part of these schools' initiatives and what the statutory requirement for schools in Wales is that we have to follow a skills-based curriculum. And the skills-based curriculum consists of literacy, numeracy, and something called digital competency, okay? So one of the reasons why I was very interested in taking part in this was because I felt that we weren't very familiar with DCF and we weren't where we should have been for DCF, and I wanted to see how we could improve our DCF teaching in an effective way that doesn't compromise our maths teaching, okay? So one of the things that very much interested me was with the development of AI, the fast development of AI, and the need for our pupils to be able to code and program, how then it can be infiltrated in maths lessons, that it would help actually the maths learning, especially Key Stage 3. So the proof of concept for me is used in algebra lessons, and we've scheduled it now for year 8. So at the end of year 8, in the academic year of year 8, we have timetable sessions where we will teach our year 8 pupils basic Haskell codes and programs in order to be able to then use them as a way of checking their answers in their algebra work. So if you sort of break down the scheme of work for algebra for year 8 in 5 parts, we have to look at collecting like terms, substitution, solving linear equations, indices, and forming expressions. Now, I know there's other aspects of algebra that we can investigate, but if you look at those 5 basic things there, those 5 basic things are what I would then plan and have planned to infiltrate then Haskell programming and code in our teaching. I hope I'm being clear. Is that okay? Yeah. So, as you can see, this Maths and Numeracy LOE is consisted of 4 parts. So for Haskell, I've only really looked at algebra. I potentially could look at number as well. So it is ongoing and it can change throughout the year. But my first sort of objective is to look at it via algebra, because that would be for me the natural way to start this. So that's basically the manifesto of Welsh Government and the new curriculum. And obviously, as part of this, we would say this would fit into the ambitious section, capable section, obviously the enterprise and creative contributors section, okay? So we would say that it would fit in these 2 parts. And as I said, it is a skills-based framework, which is statutory for us to teach within our Key Stage 3 lessons. So we're looking at the digital competency part of this framework, okay? And the documentation is available online via Welsh Government sources. You can look at it via the documents that are online. So I put an overview there for people who aren't familiar with it, okay? So how do I do this? So the thing that interested me was that I currently have a very able year 13 further maths group who lots of them want to do maths at university and potentially computer science or engineering at university. So I basically thought a good way of doing this successfully would be to do a collaboration project between Key Stage 5 pupils and Key Stage 3 pupils. So the plan is that myself and a select group of Key Stage 5 further mathematicians are learning Haskell programming from scratch. And then after we've sort of developed our skills and become qualified in being a Haskell programmer, we would then, through our time, start developing programs, excuse me, that we could then infiltrate in my scheme of work, so that in the summer term then, I'm confident, and with the help of some of them who want to volunteer after their A-levels, to come back to volunteer to teach my department how to then set up these programs, how to use these programs in maths lessons, so that it is user-friendly, not just for the pupils that have to do it, but for the teachers who have to deliver it. Because time and confidence and knowledge are the things that would be the obstacles for this not to work. So for this to be successful, and for me to lead it successfully, I feel I have to be at a certain level myself to be able to deliver this and expose this to my team, who I hope would then expose it successfully then to my Key Stage 3 pupils and our Key Stage 3 pupils, okay? So one of the things that I asked Ian was that because my students are giving up a lot of their time, which they don't really have, would it be possible for them to have some sort of recognition for their hard work that would benefit them in some way for university entrances and applications, and also when they go to university themselves? So Ian very kindly looked into it and has basically set up now a course, an online course via Glasgow University. And it's a 6-week Haskell programming course, which teaches us, myself and my pupils, every Thursday, how to program in Haskell, how to learn code in Haskell. Bear in mind that I have no idea, or had no idea, of anything to do with Haskell programming prior to starting this. And we're now in our 3rd week starting this Thursday. It's going okay. Obviously, as most classes, there is a differentiation of abilities, and I'm probably at the bottom end, whereas my students are at the top. So lots of my very able students who are doing computing IT A-levels and are wanting to do computer science at university are actually helping me learn this and make this effective then for me to then be able to ambitiously use this in my scheme of work at the end of year 8. Okay, am I being clear? Is everything clear? Yeah, okay. So at present, I would say I'm very much a beginner. I'm still learning basic code. I only yesterday did actually understand something that I did on Thursday. And obviously being head of department and a maths teacher in general, you know, time is a factor that will go against me. So I have to make sure that I organize this in such a way that it's not eating too much into my teaching time, but it is actually going to have a positive impact then at the end of year 8. So hopefully this will be a successful project and will have a successful outcome. Okay. Does Neil want to now look at the first program I tried to make?
Yeah.
Fantastic. Yeah, I'll share that now.
I think you have to stop sharing first.
Oh, okay, sorry.
Session. Here we go. Should be seeing a Google Chrome tab. Oh, I need to click the share button. There we go.
Okay, so for today's session, myself and some of my pupils wanted to sort of introduce how potentially this could be used in a maths lesson. Bear in mind that we have to cater for a range of abilities in our pupils. So we want this to be successful and user-friendly, not just for our pupils, but for the staff who've got to deliver it as well, okay? So this is some basic code that I've learned at this stage. I know it can be improved, and Neil will show you in a minute how this initial programming code can be improved. But as I said, I'm a learner. I'm at the very, very initial stages of my path. So what I've got here with the help of my students is just a basic substitution program that I could use potentially in a Year 8 lesson in the summer of 2024. So it's just a substitution question. So how is it a proof of concept? So what I would do is, for example, if with my Year 8 class, if I was to teach them basic substitution and look at substituting integers into expressions, b squared, 3b, 4a plus 3b, etc., having set some values. Procedurally is a procedural skill, as we know. So procedurally, I would teach it to them at the board or use whiteboards, etc., give them some questions to try themselves, which they would then use their skills in class to do procedurally. So then the point of this then would be that they go to the program, and so they learn how to code it themselves, and that would be quite ambitious. So we'd have to scaffold it, and really the teacher would have to deliver it and pretty much tell them what to do. But that's okay, because they're learning then how to code. Even though they're told how to do it, it doesn't matter. They're still learning coding, and they're still using coding in their maths lesson. So they would create then this program, and it's a way then of checking their answers. So, so Neil, if I could get you to type in some random integers for A, B, and C.
Sure, I'll go for something nice and small so I can think about them as I go.
That's lovely. So you would say in class, you'd say, show me on your whiteboard what's the value of b squared, and then you'd hope they would say 9, yes, and then if they type that then in their program, it would tell them whether or not they were correct. And then obviously then there's options then that if they weren't correct, so for example, if he accidentally now put a wrong answer in here, I trust he knows how to do 3 threes, but let's assume that he accidentally made a mistake, that the program then would show that it was incorrect. So it's a basic form of proof of concept, a very basic form, but needless to say, it is hitting that target of they're learning how to code, and they're learning how to create a program that could potentially then help them understand and improve their skills in substitution. So it's hitting then two avenues. So it's improving their maths, which is what my objective is, but also it's teaching them coding, and it's teaching them programming in order to then utilize it and use it to help them learn, which I think is the objective of the DCF. Okay, and if I'm wrong, I apologize, but that's what I read as being the objective of the DCF. So as I said, it's in its very initial stages, and I know Neil will now show you a better way of improving that code, because what I've done there is what's called a Haskell. Ian, remind me again. Sorry, it was Haskell.
This is a procedural implementation of the algorithm that you've designed, and it's what we're calling technically a domain-specific language. So we're basically going back to first principles and saying, when programming was invented, one of the earliest innovations was a language called Fortran, and then another language called BASIC, which teachers will be familiar with who've been through the university system in the last 30 years. So we start with a code, an imperative code, which is implemented in Haskell, but Haskell is primarily used as a functional programming language. So I asked Neil to recode this as a Haskell implementation in the REPL environment, which we're using to share code between the students in phase classroom and those of us who are coaches to the project. Neil, do you want to just explain a little bit about what was involved here in moving it across?
Sure. So I want to emphasize this is not an attempt to be an improvement at all over. Faye is starting a journey very early on, and I'm a domain-specific expert in Haskell. The key I would like to draw attention to is that there's two different approaches made here. But in terms of the fundamentals, if you look at the syntax is here, the fundamentals of Haskell are the same for both. I'm not using any more clever tricks of the trade or anything hidden underneath. Like all the fundamentals that I'm using, the same fundamentals that Faye has learned in the past 3 weeks. They're both the same. It's just a different approach to the problem. And if you compare the two, I guess what I say for Faye's approach, it starts off with, well, grab all 3 numbers, and then you start slowly going through all the different formations of building up all the answers at the start, and then asking the questions, checking the answer, and so on and so forth. It's almost got a shopping list of stepping through. In terms of where things would start to head toward as she starts refining her learning, and as the students as well start refining their learning going through the course as well, we'll start seeing more higher order functions and more confidence using those building blocks. So instead of getting all the answers at once and then building all the iterations, is maybe writing a function to take the question and the answer and remove some of the repetition of laying things out line by line. And particular to that is that you see the levels of indentation here that kind of go further in, and what we'd expect to see as well as they kind of start thinking about things in more kind of a type-oriented function is that indentation kind of begins to reduce as they start putting types and functions into higher order functions as well.
So just to finalise, for this to be successful for my department, for this to actually be used effectively, I would only anticipate really making 5 solid programmes for the end of year 8 because of time more than anything. And we do have laptops in the department. We're very fortunate with those resources. So we can share those laptops within classes, and then using REPL, then we would basically get the pupils then to type in the code, and we would explain what the IO means, and we would explain the get lines, and we'd explain basically how they would sort of create the coding path. But in order for that to be done effectively, my team have to be confident with it as well. So by December, I'm hoping to be, I wouldn't call myself ever an expert. I don't think I'll ever be an expert in this, but I'd like to be, by December, I'd like to be confident enough to be able to then pass my knowledge on to my team and get them then to start learning how to Haskell program similar to myself. So the skills that I've learned from the Glasgow University course, provided obviously I do them well enough and are successful in actually achieving the qualification, I would then pass on to my team. And then in the spring term, very slowly via departmental meetings and looking at the select team first. I probably wouldn't look at the whole department to start with. I would probably only look, because I have a big department, I've got a department of 13. So I would probably only look at about 3 or 4 of them at first. And then with those 3 or 4 members of my department who wanted to then do this with me and were keen to do this with me, I would then teach them how to do this. And then the objective then is then in the summer term, after the end of the summer exams, we would then devote about a fortnight of the year 8 curriculum to this, because that's what we planned in the scheme of work, so that myself and that team of about 4 teachers would then teach it to our year 8 students in a planned and very controlled environment.
Yeah. Thanks, Faye. I think that's a very full description of the project that you're planning. Perhaps we should invite questions at this point. It may be that some of the syntax is new to people in the room here. but the semantics, the meaning, as Neil points out, the meaning of the procedural implementation and the functional implementation are the same. We found in earlier experiments with Haskell in primary schools that students who come to programming through functional programming first, rather than through Scratch or Python, don't have any problem visualizing what functional application actually amounts to. So the expectation is that at the end of year 8, somewhere between these two implementations will be accessible to the students ultimately. The teachers will have sufficient confidence to introduce it to the students. And then the same phenomenon that's happened at Key Stage 5 may well happen at Key Stage 3, that the students begin to teach the teachers.
Yeah, and that's probably then where obviously we'll have, because we set in Stanwell from year 9 onwards, but we have banding in year 8. So we'll have, very able students who will be our future further mathematicians, who will probably go away and then make new programs themselves, and would then challenge themselves to making new coding, which is excellent, because then you're sort of opening a platform for them to start looking at coding and programming, because they can see the benefits of, hopefully, and I emphasize hopefully, they'll see the benefits of it in their own learning of maths, and how we can help them learn it or help them check themselves, which is the proof of concept, because they're checking, they're not assuming their answers are correct, they're actually checking their answers are correct. So it's a very basic form of proof, admittedly, but it's still a form of proof. But something then, over time, because it's in extreme initial stages, over time you would hope then that if it was successful, then this would develop then into further avenues as it goes along. But as I said, it can't ever do that unless it starts. So this is a starting point.
Yeah. Are there any questions? I know there's some very distinguished teachers and former teachers in the room here. John, have you any comments on this? I know you've followed our work over the last few years at ATM conferences. Or Johnny, if he's still there. Johnny's not there. Oh, Johnny is there, yeah. No? Okay.
Faye, sorry, Ian, can I jump in with a question?
Of course, please do, yes.
Yeah, no, I was the head of maths in Wales. I was head of maths at Cateys for a few years before I came into this and moved into teacher education. What I'm interested in is that obviously there's not a national approach yet in Wales as to how to implement the DCF. And I just wondered, in terms of how does it tie in with your computing languages, for example, that are offered in the school? So do they offer Python, for example, in year 9? And does it tie in that way? Is there a link across the groups? Or?
Simon Matthews, who's our new head of IT, he's been really helpful and has been involved in this as well. And he did question why we were using Haskell, not Python, because they use Python in their lessons. And the pupils who do IT A level also said, we prefer Python, Mr. Haskell. And I said, if I'm honest with you, I said it's something that's been offered. And I suppose my point of view is, at the end of the day, they're learning some form of code. They're learning programming, okay? And I appreciate that there are probably better things to use, programs to use, different tools to use. But at the end of the day, like I said, it's a starting point. So it's just a starting point to introduce DCF in what I would like to see then a purposeful way, not shoehorned in as a waste of time, it's just another tick box exercise that's just going to fail, and which, as you understand, in education, we are thrown a lot of these things, and, for them to be successful, they have to have meaning to the teachers who are delivering them, and also the pupils who are having to have them taught to them. So I wanted it to be purposeful to my pupils. and I wanted it to be purposeful to my team. So that's why I sort of demanded that my sixth form who were helping had something out of it. Yeah. And the good thing now is that with the Glasgow qualification, lots of them have put that on their personal statements for university.
Yeah.
So they've benefited from that. Yeah. And also as well, you know, when I asked them, you know, is it too much on a Thursday after school? They said, no, it's fine. It's fine. You know, and because it's this side of Christmas, it doesn't then impact on their A-level studies revision. So I think it's going to be then okay and would be manageable for them. So it's very organic what I've done. You know, this could have completely failed. But I think that's the risk you take, isn't it? You try something and then if it works, then wonderful. And if it doesn't, then you review it and think, chuck it in the bin. But I think that I think there's a lot of potential with this. There's a lot of potential with this.
I do get asked a lot of questions because where I work is a bit of a crossover between the East Wales schools, the Monmouth and Chepstow sort of area. So we do get a lot of people asking me, what can I do for DCF? Compliance, if you like. So it's very interesting. Thanks very much for that.
Not a problem. As I said, I am totally new to this and I'm learning. And, you know, it's quite funny that one of my sixth formers is teaching me how to do it. So she's tutoring me at the moment, which is wonderful. But then I suppose that's not a bad thing, you know.
David, you asked about the relationship with Python. The next session C, if you're able to stay on for it, we'll be looking at the progression from this entry level in Haskell as a foundation into Python.
Okay.
And they're very complementary. And more importantly, the tools that we're advocating or investigating, this REPL.com environment, which is an experimental environment free to schools to use with limits on its capacity because it's free, but it seems to be doing the job at the moment. It lets the students develop their code and share it through the teachers with approved code and resources, which can be made publicly available. The Welsh Government have asked two questions of the proof of concept. One is, are the schools interested in it? And the second is, does it scale? And we can't imagine how it might scale unless it costs nothing, because 0 times anything is still 0. But to make it cost nothing, which means we're using free resources all the time and using them at the bleeding edge of technology, we seem to have found a platform that will work for scalability and therefore reduces the effort that teachers have to make because they can use approved resources. And we're hoping that ATM will see its role, which has historically been to produce resources which are peer-reviewed, can move into peer-reviewing literate programs, which is what we call this kind of programming.
So he's asked a question about collaboration between maths and computer teachers. The only collaboration at the moment we have is myself and the head of IT. And that's only because it's in its very, very initial early stages. Yeah. So in answer to that question, we'd have to see this first year through, I think, with respect to the maths department first, before, with the help obviously of Simon, my head of IT, before I could actually honestly answer that question. So at the moment, it is just the efforts of the maths teachers for this academic year. So
no, I think it with my work hat on. Obviously, we know about the sort of recruitment crisis in maths education. We're getting a lot of teachers who are coming through and NQTs and ECTs, for example, who might not have come from a traditional science background, for example. So an entry into delivering coding at the side of the mathematics is, you know, the entry point is sometimes quite different. You know, if people haven't experienced a coding through university, for example, if we've had a psychology with maths background, for example. So it's what's really interesting to me is, as you say, that journey about learning something to put the digital competency framework in place, you know, having to get entry into a program in. And I think that's, you know, that's where I'm coming from with this, you know, the ease for new teachers, if you like. And
I think it'll be successful with NQTs. Because, you know, especially if you've got young staff in your department who are keen, you know, they'll probably want to get involved with this because, you know, they could move it forward and move it further. I don't think I'll have difficulty with my team with this, but I think it's manageability in terms of time.
Yeah.
So I think that's why, even though I've got a big department, I probably would just have a select few staff first.
Yeah.
Because I think there's more chance then of it being successful in the long run, yeah. Because obviously that we're going to make, you know, mistakes, and some of the team will go, I'm not keen on that fair, you know, and that's fine, you know. But then some of them will say, actually, I saw a good benefit with that, you know, and potentially then, for a school, sort of, if you're looking like at a structure within a department of opportunity then to progress your own team, you know, maybe in the future there would be an opportunity then for somebody to be in charge of, say, DCF within the maths department, who would then coordinate activities for the department. You know, so this is something to build on, you know, but as I said, it's in its very initial stages at the moment, so.
No, thank you very much.
Thank you. Thank you.
I think it's worth mentioning that the situation in Wales is different from England in the sense that the Welsh Government is committed to these areas of learning and experience, and cross-disciplinary work, and schools creating their own curriculum in the way that Faye and her colleagues are doing it. English schools have to fight against a national framework which is quite authoritative, and it makes it difficult to find space to innovate. So
there's been a question about will the exam boards incorporate within the syllabus? I don't know is the answer. I know obviously they've got new assessments planned and they're still working on them. I went to a recent consultation before we broke up in the summer regarding the new assessment in Wales. And I think, I honestly don't know the answer to that question. I could potentially see them doing it, but the only question I would have there is facilities. Not all schools have money for facilities. And, you know, money is a massive constraint for lots of schools. So can that actually help? You know, it cannot be possible. And the other thing as well is it's actually upskilling lots of staff. So you're going to have to upskill a lot of staff to be able to deliver this competently and effectively and confidently. And as I said, that's time, money, facilities, you know, it is all of the basic things that every person in education has problems with, isn't it? Money's always the problem. So I don't know the answer to that question, sorry.
On the question about maths exam boards incorporating programming, if you look at the general background to curriculum innovation across countries, the Royal Society has just published a consultation about this, which does a very good state-of-the-art review. Miles is going to talk a bit about it in the panel. The government and the exam boards don't work in isolation from the international context. And there's a movement internationally towards including technology in maths education, which is getting stronger and stronger all the time. So if the students don't find the Welsh board is in the vanguard of that movement, which it could well be, choose to be, there are other exam boards like the AQA, which are moving in that direction faster, that the schools have the option of assessing the students with. Yes, the question about the collaboration between teachers and computer teachers, I think it extends also to the coaching that's coming via the ATM work group. that we bought a number of licenses from the Glasgow Future Learn collaboration for a self-study course in Haskell over 6 weeks. And we extended that by another 3 weeks to apply it to teaching mathematics using a textbook, The Haskell Road to Logic, Maths and Programming, which is an established textbook. We know that the universities are not comfortable with students having access to high quality textbooks. They don't feel that they get access to high quality textbooks necessarily to cover this traditional A-level curriculum. So we've adapted the use of the textbook for the last 3 weeks of this course. And the idea is to create our own course, which will blend the two sets of resources and similarly be offered over a period of 10 one-hour sessions, but with self-study resources of the kind we're going to look at in the next session. So very much, Ernie, we would expect the head of maths or a head of maths and a colleague from IT to work together through the self-study materials as part of their professional learning in the first instance. And that's the target for the initiative with the Welsh Government, to create those resources.
Okay, so any other questions? Thank you for your comment, E.T. I don't know who E.T. is. Yeah, I think I'm with you. I understand you've got to do it yourself first, otherwise you just don't know if it's going to work. So, and it's having the confidence to do it and the time. So I would just say, in terms of organisation, just an hour a week, realistically, maximum 2. Otherwise, it's gonna be too much for you. So I would say 2 hours maximum a week, really, to be able to do this, like a lesson then. And I suppose the good thing with having doing the course myself is that from a selfish level, I'm gaining from it as well. So like my pupils, you know, they'll be Haskell programmers, then hopefully I will as well, which is a good recognition to have, you know. So I'm upskilling too, is what I'm saying. So it's a good opportunity.
Okay. Well, just let me make a plug then. If there are no more questions for the remaining sessions in this strand, we're going to look at the environment for teaching Haskell and Python in the next session, which will be a 10-15 minute presentation, and then we hope 20 minutes of hands-on experience with the technology in either in breakout rooms or independently, depending on the interest. And then we have Martin talk about assessment, which addresses the question of how the exam boards are approaching this. And then finally, Miles is going to talk about cryptography using a Jupyter notebook to deliver his material. And David Vaccaro will be joining us to talk about ChatGPT and its application potentially at Key Stage 5. Finally, all the speakers, Faith sent her apologies, but I'll represent her, will be together for a 45-minute discussion. It'll be led by cryptographer and mathematician Whit Diffie, who'll be joining us from Boston. He'll talk for 5 minutes on the design of a discrete mathematics course based around cryptography. And then Miles is going to talk for a few minutes on the Royal Society Maths Futures Report, which he sits on. And finally, that conversation we put out to general discussion amongst the delegates. In the past, we've had 60 or so delegates stay back, and it's been a very informative discussion. So I hope you'll be able to do that and join us in at the end of the day, if not for the rest of the day.
Ian, we're not quite ready at the report stage. All we've done is a discussion paper, but I'm very happy to talk about that later on.
Yes, well, we look forward to your 5 minutes on that and broadening it out to the delegates who've got very strong views on what they've read so far. So hopefully they'll recount them online. We've more or less used up the 45 minutes, so we could call it a day unless there are any other comments. Well, thank you, Faye, very much for
Not a problem. Thank you very much.
and for all your work. and we'll see you in 20 minutes or so. Thank you.
Thank you, everyone.
Thank you.
Thanks.
Thank you.
Thanks, well done.
Thank you.